Okay, so well, this was a question that I thought that I would just let you think of for 2 weeks. But most of you have come very close to the answer. So we can just discuss the final result also. Your friends had already figured out that if you increase the rotations per minute, the car will consume more fuel. If it consumes more fuel in a given time, well, the fuel, when you burn it, it's doing some work. It is adding energy to your system, doing some work on your system. The work done, the more fuel you consume, the more work that there will be done per unit time. So the power input from the fuel, burning fuel, is increasing. So if you increase the rotations per minute of your car, the input power will be increasing. The efficiency of the car will be more or less constant. It will not change. But that means the output power, that is the power that is causing your car to move, is also increasing. So increasing RPM means your output power is increasing. A larger RPM means larger output power. Now the last step of this discussion is, how is the power related to your speed on a hill? You also need to find that relation. We all have this intuition that if the car is stronger, if it has a larger power, then it should go faster on the hill. Okay, that we almost all have this correct intuition. But we have to go one more step. What is the relation between the power and the speed on the hill? That is we should find. And that relation is in fact over here. So suppose you are on a hill. This is your hill. Its slope is determined by this angle theta. This is your car. We are interested in the maximum speed that your car have. That is, it is moving at constant speed. This is Vmax. It is moving at constant speed. Its acceleration is 0. But we know that it has a weight. And the weight has a component along the hill. And the component of your weight along the hill, if you take this as your positive z direction, is equal to minus m times mass times g. This is the weight of your object times sine of that angle. Sine of this angle over here. If it is moving at constant velocity, constant speed, the engine of the car should provide a force which will balance this one. So the force created by the engine should be equal to minus this force, minus because it should be in the opposite direction. So it should be equal to m times g times sine of theta. This is the force that the engine should provide. Well, we know the power of the engine. Let's say this is the maximum power the engine can provide. This should be equal to, well, the power is equal to the force times the speed. This is the force that the engine is providing, m times g times sine theta, times the maximum speed. So the maximum speed on the hill of a car whose power output is given by P max is equal to the maximum power output divided by mg sine theta. So this also tells you how the maximum speed of your car changes with the slope of the hill. So the steeper the hill, the larger the sine theta will be. Since if the sine theta is large, the maximum speed you can achieve will be much larger. Of course, this is ignoring any friction force. Because if you consider the limit sine theta is equal to 0, that is a flat surface, this formula tells you that your maximum speed is infinite. But that also makes sense in the absence of friction. In the absence of friction, your engine is providing you some force, that is, there is an acceleration of your engine, of your car, and the acceleration can go indefinitely. There is nothing to limit that. within this description, of course. If the acceleration, your car can accelerate indefinitely, then the maximum speed it can reach is infinity. So even that limit makes sense in quotes. So now we know all the relationship between how the RPM affects the maximum speed. If you double your RPM, you will be doubling the amount of fuel that you use per second. That is, you will be doubling the power input to your car. If you are doubling this P in, assuming that the efficiency will be constant, it is more or less constant. You are doubling the output power. But if you are doubling the output power, this just tells me that you are doubling your speed. So if you increase RPM, you are doubling the maximum speed that you can reach uphill. Well, I have never seen an engine like a line. Yes. RPM, okay, that's... Well, this is what your friend tells me. RPM and the fuel consumption. So that graph, your friend tells me that it is like this, more or less, right? Okay, fine. Thanks for the information. So if you double the RPM, this tells me that you are not necessarily doubling the fuel, but it will be just a factor close. Well, what is the slope? This slope. Well, it doesn't really matter. If you would have gone along this line, in that case, doubling RPM will double your fuel. But since you are along such a line, if you double your RPM, your fuel consumption will not be doubled, but your power input will not be doubled. Now, this is just a very simple model, which gets the main idea, I think. Things will get more complicated when we study the torque, the rotational motion. Any questions on this one? Okay, so here we have another question. So this is the potential energy you have. It is a line in negative x, and it goes like bx squared for positive x. Can you identify a physical system which behaves like this? If there is friction, you cannot talk about potential energy. If there is friction or tension, they are not conservative forces, you cannot talk about the potential energy of friction. Okay. If you are going, what do you mean you are going upwards? You mean positive x? Are you going in the positive x direction? Well, if you are in the minus x and you move in the positive x direction, your potential energy is decreasing and then increasing. What is the force corresponding to this potential energy? If you are in the negative x region, what will be the force? Minus ax or plus ax? You are in this region. What is the force that gives this potential energy? Plus x or... Well, the force is minus the derivative of the potential energy. I'm in this region, so my potential energy is minus ax. If you take the derivative of this thing with respect to x, it is minus a. Minus a is a. So in this range, I have a constant force equal to A. So what examples do you know about a constant force? Free fall, weight. Weight is a constant force. Okay, let's study this example, this range. When my system is at positive x, this is the expression for the force. For the potential energy, what is the force? It is minus 2bx. If you take the derivative, it is 2bx minus the derivative is the force. So it is minus 2bx. Do you know any example of a force which goes as minus some constant times x? You do know such a force. Try to remember. The force is proportional to the distance. Gravity, we just said that it is constant. So we had just said that the force is A if x is larger than 0 and minus 2b is a constant x for x less than 0. Or you can just write it minus kx, k being 2b. So when I said the k, you remember the spring? A constant times x. You always think that this is kx. Okay, kx, we always use the symbol k, but we can use any symbol. It is just constant times x. That is the spring though, with a minus sign. So here we have, at x larger than 0, we have gravity. At x less than 0, we have gravity. At x larger than 0, we have a spring. So I can just think of this system. I have a spring over here. This is my x equal to 0, or let's say this is my x-axis. This is x equal to 0. So here I will have a constant force in this direction. It will not be mg, it will be mg times, if I take this angle as theta. If I put my mass over here, it feels a force, mg cosine theta, mg sine theta. It is constant. When it starts compressing the spring, well, there is the gravity plus the spring force. That we have two forces there. Over there, I only have the spring, but we can say that the force of the we are considering a system where the force of the spring is much larger than the gravitational force. You can just imagine that this is very flat. So when the spring is compressed, you can just ignore the friction, ignore the gravitational force. It will be only the friction force. So this will be our system, more or less. This we had seen the video of the system on Tuesday. So the question is, true or false? The motion is periodic. Is it periodic or not? And that is the phone number at the top that you should send your replies to. I will check what you are voting on. You will not be seeing them. Okay, so the time has begun. A is true, B is false. Is the motion periodic? Then of course I want you to explain. If you say yes, why is it periodic? If you say no, why it is not periodic? We will discuss it after you send your answers. I already sent my answer. There is no friction. Come on, this is one of the very few courses that you will have where the instructor will ask you to have your cellular phone with you. Come on, there are only 20 answers yet. Come on, there are about 60 people here, but there were only 24 votes. Take your chance. You have a 50% of getting the right answer. Be a bit optimistic. So anybody who wants to explain why is it periodic? Why do you think it is periodic? So you are saying that the video was showing that it was periodic, in a sense. But suppose you couldn't imagine that this potential energy corresponds to such a system, a spring and a constant force at the end of an incline. Just looking at this graph, can you say that the force will be periodic? It's not periodic? So, okay, so you think that it is not periodic. First, let's start with what do we mean by periodic? What do we mean by periodic? What is it? Okay, if the position is a function as a sine of some omega t, it is periodic, but that is a special case of periodic motion. This will not be a sine function, that is for sure. So what is periodic? Yes, I mean, if you look at the sine, this is a sine function more or less. If you just go back and forth, this will be more or less a sine function. But I can, for example, do this motion. Then go back. And repeat the same thing. This is definitely not periodic. This is definitely periodic, but not sinusoidal. So the question is this periodic? Does it repeat itself? Well, if there is a potential function, it is a conservative force. That is by definition. For a non-conservative force, you cannot even talk about the potential energy. Yeah, more or less. But okay, back to our question. Why is this periodic? Why is it not periodic? Anybody else who wants to comment? Yes. Sure. Okay. Now I release it. Okay, so I release it here. So at this moment, this is the potential energy. So the force is minus kx, k being twice b times p. So it will feel a force in that direction. So it will accelerate in that direction. It will accelerate, and then it will eventually reach this point. Then it will move to the x smaller than 0 region. When it is x smaller than 0, then it feels a force in the positive direction with a magnitude a. It feels a force a in the positive x direction. Since its velocity is in this direction, it is slowing down. It will slow down, and when it reaches here, its speed will be 0 because the kinetic energy is 0. Since I'm releasing it at this point, let's say at rest, its energy, total energy, is at this level, which is conserved, since we are talking about the potential energy. So it reached here. It is at rest. It doesn't have any speed, but there is a force acting on it on the positive x direction. So it will start accelerating. It will accelerate until it reaches this point. It will have some velocity. Its kinetic energy will be this much. After this point, it will feel a force in the minus x direction. If you want to discuss about the force, it will feel a force in the minus x direction. It is decelerating. Or you can say that its kinetic energy is decreasing, so it is decelerating. So it will slow down, and when it reaches here, it is at rest with its initial energy. So I released it under certain conditions. It went and then came back, and when it came back here, its conditions are exactly equal to the initial conditions. So initially it was at this point at rest, it went, it came back, now it is there at rest. So it can restart the same thing again. So it will just repeat the same trajectory. So that tells us that the subsequent motion is periodic. Now, if you have a potential energy and you have two turning points, the motion is always periodic because of the same reason. If you leave it at this point, it will go. If there's a second turning point, it will go to the second turning point, then turn around, come back here, and start the same thing over again. If you have such a potential, this is a potential that you will see quite often in your career. So if this is the energy of your particle, then this motion is not periodic. Because if you send your particle in that direction, it will come here, it will reach this turning point. When it reaches this turning point, it will turn around and it will then go to infinity. This is not a periodic motion. But this will be, a motion with this energy will be periodic. Because if you release it here, it will go there, come back here with 0 speed, and it will just repeat it all over again. Yes? This potential. Well, this one. So let's say if I throw this thing towards you, okay, and I miss you barely, well, there's a potential energy between this and you. If there was nothing else around, this would have first came to you, so its radial distance will decrease, and then it will go until infinity because the potential energy is not small, the attraction is not strong enough. So it will come to you, the potential energy will drop, but then after some point it will go away from you, meaning that it will go to infinity. This is not a quantum mechanical object. No, let's not discuss quantum mechanics here, though. I mean, you will take quantum mechanics courses in 2 years. Don't worry. Or we can discuss after the class. I will. This is the question. The velocity is a continuous function of time. The velocity doesn't change from, let's say, 5 meters per second to 10 meters per second in an instant. Okay, so there's a problem in the system. Your votes will probably not be accepted. So I want to see hands. The velocity is a continuous function of time. If you think that it is yes, you should raise your hand. If you think that it is no, you shouldn't raise your hand. Or if you think that it is yes, raise your hand. If you think that it is no, stand up. Otherwise, don't do anything so that I will know who doesn't answer. If you think no, stand up. If you think yes, just raise your hand. Okay, I want everybody either to raise their hand or stand up. Keep your hands up. Okay, everybody either raise your hands or stand up. Or if you want, we can just move the game to the left or to the right. Okay, so those who say yes, this side. Those who say no, to that side. Yes, no. So, okay, everybody choose us one side. Okay, so first of all, why no? Why do you think the velocity is not continuous. Okay, force is not continuous, so you say that the velocity depends on the force, so it's not continuous. No, you had some comment, right? You mean the velocity, the speed? Okay, if you look at the graph, let me make this representation. This is my x equal to 0. The kinetic energy at this point is given by this. It is not 0. The speed is not 0. So anybody, any other comments? Why no? Why yes? Just like what? Like this one? Okay, so this is also the acceleration, you can imagine it. So, any other comments? There is one explanation. One claim that the velocity has to be continuous. Okay, so you should move to that side. Okay, so your friend is saying that at x equal to 0, we cannot take derivative, meaning probably that at x equal to 0, we cannot talk about the force. Is that what you mean? Well, I would like to correct this expression. It is not, let us just change that to from x smaller than 0 to x smaller than or equal to 0. Let me just make that very small change. So there is another claim why it should be discontinuous. Any other claim why should it be continuous? Yes. Okay. Sure. Okay, if somebody else wants to make a comment while your friend is drawing. So that side won one person, by the way. You lost one person. You should try to win all the other people. So you think that is the velocity? So let's see. You start from here. You start at 0 speed. Then you are saying that it is the speed is increasing as you go there, and then it is decreasing and then stops. Well, okay, I mean, you just talk about the absolute value if you like. So it just goes positive. It's always positive. So you say that this is the graph. Okay, so anybody who wants to oppose their claim? They say that this is the graph of the speed as a function of time, and hence it is continuous. Let's not go to the mathematical technicalities. I disagree with him. So, okay. So, what do we mean by discontinuity? Okay. So, this will be a bit mathematics, but let's first specify what we mean by discontinuous. If there is a function, it is discontinuous. It is change across a very small interval is 0, is finite. So this is a discontinuous function, because if you look at the value of this function at this point and the very nearby point, they differ by a non-zero value. So that is why we say that this function is discontinuous. Well, the change in the velocity of an object is equal to the acceleration times the change in time. Well, the acceleration is always finite, because the force, although it is discontinuous, it is finite. If acceleration is a finite number, the smaller I make dt, the smaller the change in dv will be. So if I take this change to very small values, the change in the speed will be very small. That means it will be a continuous function. Because in this example, the change in the acceleration is never very small, independent of the size of this length. The change in acceleration will be very large. It will be this almost. It will not get smaller than this one. But the change in the speed, I can make it as small as I want by changing this dt. That means it's a continuous function. Okay, so anybody wants to go to the other side now? No, okay, so you stick with your opinion. That's good. I mean, if you believe that something is correct, you should stick to it. That's good. Anybody? So you are all sticking with your idea that it should be continuous. It should be discontinuous. It is not something that I didn't do before. Şimdi I'm repeating the same thing I said in Turkish. First of all, let's clarify what we. Öncelikle süreksizden ne anlıyoruz, bir onu netleştirelim. Ona göre tartışmayı devam ederiz. Süreksiz ne demek? Mesela bu süreksiz bir fonksiyon. Şimdi ben eğer ivmenin değişimine bakacak olursam, x eşittir sıfırın hemen solunda ve hemen sağında, bu her zaman için sıfırdan büyük olur. Hiçbir zaman sıfıra gitmez. Hatta bu örneğe bakacak olursak, işte şurası a0 olsun mesela. Bu fark büyük eşit a0. Hemen solundaki ivme ile hemen sağındaki ivmenin farkı. Eğer bu koşulu sağlıyorsan, o zaman süreksizdir bu fonksiyon. Şimdi ben hızdaki değişime bakıyorum. Hızdaki değişim dediğim şey belli bir zaman içerisinde ivme çarpı o zamanın değişimidir. Şimdi diyorum ki ivme sonlu bir sayı. Grafikten onu görüyorum zaten. İvme yani ya a0'a eşit ya da işte bu değerlerden birine eşit. Ben her zaman sonlu bir x'de olduğum için yani değeri ne olursa olsun sonlu bir sayı ivme. Ben şu zaman aralığını çok küçültebilirim. Zaman aralığını ben küçülttükçe hızdaki değişim de azalacaktır. Yani hız belli bir zamandan hemen bir sonraki ana kadar belli bir değerden bir başka değere atlamayacak. Atlamıyorsa eğer bir değerden bir başka değere, şurada olduğu gibi, burada x'in sıfırın hemen sol tarafından sağa geçerken ivmenin değeri bir değerden bir başka değere atlıyor. Ama hızın değeri zaman içerisinde en azından belli bir değerden bir başka değere atlamayacak. Hemen yakınındaki değere geçecek. O da bana diyor ki hız süreklidir. Zamanla sürekli bir şekilde değişir. Evet, sizi ikna edebildiysem sizi de öbür tarafa alayım. When the speed changes discontinuously, well, it requires the acceleration to be infinitely large. If the acceleration is infinity, even when you say dt, when you set dt to 0, infinity times 0 can be a finite number. That will be a limit when the speed changes discontinuously. In reality, we never have such a case. because infinite acceleration means infinite force, but we can approximate it. If you just take a ball, throw it on a wall, its speed changes almost instantaneously from this direction to the other direction. So it is almost discontinuous. Almost, not exactly. No. The speed in real life is always continuous. Okay, now. So anybody else moving? So is it peer pressure or are you really convinced? Mahalle baskısı mı var yoksa gerçekten ikna mı oldunuz? No, I'm still interested with these guys. So you still insist that the speed is discontinuous? Yes. Okay, now our time is up. Good luck in your calculus exam. We will see you on Tuesday. For those who would like to discuss, we can continue for 5 more minutes in the class.